Well, I'm Tom Campbell, and as advertised, I am a physicist and a citizen and explorer of the larger reality. I started out doing experimental nuclear physics, then I joined the real world and did analysis of large, complex systems. When I mean real world, I mean outside the cloistered halls of academia. Now, professionally, after failing 2 times in a row at retiring, I'm a consultant, and that means I get to work on the problems that are too hard to solve otherwise, or that need the experience of somebody with, say, 40 years in the business. Right out of grad school, I hadn't been out of grad school very long when I ran into Bob Monroe. Bob Monroe had just built a laboratory to study consciousness. There was nothing in it. It was the shell of a building, and he was looking for scientists to help him man his laboratory. And I had done a little transcendental meditation and knew that reality was bigger than what it seemed. So I jumped at the chance and I made a deal with Bob. I said, Bob, you teach me what you know about out of body, and I'd be happy to work here in your lab and study consciousness. Well, that began about a 10-year collaboration with Bob and myself. The first 5 years or so were pretty intensive. Bob stuck to his word. He did teach us how to do out of body, and myself and others, wasn't just me, but there were others who also then were kind of permanent fixtures around his laboratory. We were also the guinea pigs in all the experiments that we did. So what we did there is study consciousness. Once going into the larger reality, sometimes called an OBE, an out-of-body experience, once that became almost as easy as breathing, then because I'm a physicist and I want to know, how does it work? What are the limitations? Where does it come from? That's what I did. I spent my time in the larger reality doing experiments, doing physics, trying to find out how it worked. What were the limitations? What could you do? What could you not do? And how did all that relate to the rest of the world? And what were we, who are we, as consciousness? How does the world work in general? And about 35 years, once you start down this path, you never back up. It's always one step, a little further down the path. About 35 years go by, and I was asked by a visitor, well, Tom, how does the world work anyway? What is this reality? How does it work? Well, I started to try to explain it and decided I needed to write it down. And as I wrote it down, I passed it out to people to say, what do you think? Could you understand it? And of course, they rolled their eyes and said, no, what about this? What about that? So after passing it around, I don't know, a few hundred times to 10 or 15 different people, I ended up with enough text to make 3 volumes. And that was, the My Big Toe. Now, I call it My Big Toe, not because I'm so proud of it that it's mine, but because if it's not your experience, then it cannot be your reality. You have to have the experience yourself. Reality is personal. Okay. Consciousness is individual. Well, it turned out that the same scientific principles, if you will, the same theory that explain consciousness, and paranormal, and out-of-body, and all the things that we were doing at Monroe's lab, also explains better physics. So it turned out to be, that's not the way I approached it, but it did solve physics problems. Matter of fact, the 2 most fundamental and intractable physics problems modern physics have to do with the basis of quantum mechanics and relativity. Relativity is built on the idea that the speed of light is a constant. Now, we all know that that's the fact, and it's been measured many times, and that's one of the statements that Einstein made that made him very famous. The speed of light is constant. But nobody knows why. Why should it be a constant? Nothing else is invariant like that. Only light is the only thing. Well, this theory explains why c is a constant. It logically derives that fact. The other big mystery is in quantum mechanics. Particles are really just probability distributions. But how is it that the fundamental of our physical world is just a probability distribution? It's not even a real physical, objective thing. How could that be? Well, it's a big mystery. Nobody knows the answer to that question. All they know that if they make that assumption that underlying reality at the small level is probability distributions, they can compute answers that are verified by experiment. But nobody really knows why. And that explanation, derivation, if you will, of why reality is probabilistic also falls out of this theory. So it does better metaphysics and it does better physics. But today, I'm going to talk to you about both consciousness and physics, a physics that supports rather than denies alternative approaches. Also about holism. Now, my concept of holism is working from the biggest picture possible. It's a matter of getting into the big picture and understanding things, little picture events in terms of the big picture. And that, of course, will lead to health, physical, emotional, mental, and spiritual. And unless you approach health from all four of those, physical, emotional, mental, and spiritual, then you're not really approaching it from a holistic viewpoint, because we are all of that together. And you cannot heal any piece of that if you're going to ignore the other parts. We have to work with the whole person. Okay, holism is about seeing a bigger picture, being aware of the context as well as the event. There is holism within physics as well. A big picture view of reality must see the subjective content as well as the objective facts of our existence. So we're going to expand physics now out to the subjective as well as the objective. Indeed, physics evolves by becoming aware of bigger pictures. Then the old smaller picture becomes a subset of the new bigger picture. Here's some examples. Once flat Earth was a known fact. It was replaced by a spherical Earth. But the flat Earth becomes a really good approximation for small distances. If you're laying out a football field, you don't worry about the curvature of the Earth. It's irrelevant. It's too small a detail to worry about. Okay, Newtonian physics was replaced by relativity and quantum mechanics. Newtonian physics was once the final answer. It's now only an approximately correct view within the limits of low velocity and in the macro world. You see, so this is a trend. Each revolution in concepts, each holistic step up, was a mighty struggle of a known accepted truth, eventually being replaced by a larger, more general, more holistic truth. A slow process, an uphill struggle. People don't want to change. And now, relativity and quantum mechanics are on the cusp of becoming a subset of a larger, greater truth, a more complete and holistic science. Though most physicists are not yet aware of that fact because it's still very early in the struggle for acceptance. However, it will eventually be accepted because it provides more productive science for all sides. The truth is not fragile. You know, the Greeks logically proved, if you will, that the Earth was a sphere some 200 years before the rest of the world got it. So it takes a long time to change paradigms. Okay. Now, Einstein searched for a greater truth in the last 20 years of his career. It was called unified field theory, and it was called a TOE. A TOE is an acronym for theory of everything. It's a common physics word, TOE, theory of everything. What he wanted to do was, he saw that quantum mechanics had this assumptions that it was based on. Relativity had these assumptions that it was based on, and the two sets of assumptions were incompatible with each other. Each one denied the other one was real. So he knew that because of that, the answer must lie in a bigger picture. Those two were just to be derived from something else, and that's what he called a unified field theory. Well, he failed to do that. That was what I would call a little TOE, because it would have given one overarching understanding of all of objective reality. But as we all know, objective reality is only a little piece of reality. Most of us live in a subjective world most of the time. You know, all of our important decisions, do we go to college? Who do we marry? Children, all of these are subjective decisions. We don't have enough data to make objective decisions most of the time. So we live in a subjective reality. Okay. Well, what's necessary? We need a big TOE to expand the scope beyond the objective world, to logically explain the subjective as well as the objective, metaphysics as well as physics, mind as well as matter, the paranormal as well as the normal. All of these things are part of reality. And you think, oh, that would be wonderful if that happened. Wouldn't that be great? But, no time soon, right? That sounds like something that's far away, because physics and metaphysics, the normal and the paranormal, appear fundamentally incompatible. That's just because we're seeing reality incorrectly. Just as the rest of the world thought that if you lived on the bottom of that sphere, you'd fall off. You see, they were missing some information, some things they didn't understand. Okay, well, quite the contrary. Such a science is indeed already known. The physics community is ever so slowly growing toward embracing a more holistic reality based on information rather than space and matter. In such a theory, the old objective reality becomes a subset representing an approximation within the bigger picture. Now, in this approximation, the scientific method only applies to an approximately objective reality. Objectivity becomes a subset. And the conditions of this objectivity depends on only when the rule set, I'll define what that means, only when the rule set allows very little uncertainty. Okay, the larger reality is a probabilistic and statistical reality based on information, just as the double-slit experiment says it is. Okay, now we're going to get into a little basic physics, the fundamentals of reality. I'm going to explain to you the famous and perhaps even infamous double-slit experiment. This is where it all began. This seminal experiment told us something very important about the nature of reality. But just as the Greeks told us that Earth was a sphere 200 years before that fact was accepted, well, not because they didn't know what the Greeks had said, not that they couldn't follow the logic that the Greeks had used, but, you know, it just didn't make sense, right? People on the bottom, everything on the bottom would fall off. It didn't make sense. And now we're nearly 100 years, actually it's like 80 plus years, nearly 100 years past the time when this experiment was performed, and heads are still firmly in the sand. Because, well, it just doesn't make sense. There must be some other explanation. Physicists today simply call it intractable, weird science. That means they don't know. And when working on things that are intractable is a career killer, not a career maker. You go on and do the things that you can do. You don't keep banging your head against the wall that seems never to yield. Okay, so that's what's going on. Now I'm going to give you a little description, a very quick one. I have to apologize up front. You know, to tell you about this properly would take a couple of hours, and I'm squeezing it all in best I can into an hour. So I'm just going to jump from the top of this peak to the top of the next. I'm not going to be able to do any derivations. I'm not even going to make it seem particularly rational or logical to you because it just isn't that much time. In the books and in the presentations I've done on YouTube, if you want the detail, you can go there and I'll show you later where you can find it. So now we're just going to hit the high points. Okay, about this experimentation. For a long time, people were aware, scientists were aware, that if you sent a wave like light toward something like this, barriers with two slits in them, what you'd end up with is a diffraction pattern. This is a diffraction pattern. What we have is little points of light here, separate points of light, and dark spaces in between. All right, so the light comes through here, and it makes this slit and this slit appear to be like two separate sources. They interfere with each other, and you end up with where the interference is positive here, where it's negative, you get the holes in the middle. Okay, you notice that you have a bright spot right behind this barrier, and right behind these slits, you have nothing, no light. Okay, that's a diffraction pattern. Okay, now that had gone on for decades. That was common knowledge, and Einstein discovered, working with the photoelectric effect, that light comes in little discrete units of momenta. Well, that's a particle. That's how you define particles. They called the particle a photon. But this made a really big dilemma within the physics community because light is a particle, light is a wave. How can it be a particle and wave both? Because if you throw particles at this arrangement, this is the same arrangement, you expect the particle to go straight through and make a spot of light right behind the slit. That's what Newton told us. Things travel in straight lines unless interacted upon by no exterior force. There's no exterior force there, so they should have had, if light's a particle, you should have a little bright spot there and a bright spot there and darkness everywhere else. So they decided it must have something to do with there were so many particles. But that really didn't make sense, because when you shine a light beam as a wave, there's billions of photons. And said, well, it has to do with the numbers, but nobody had any idea how that might work. So the experiment was to say, let's shoot these particles one photon at a time at these slits and see what happens. Well, of course, what they expected to see was this. One photon at a time has to go through one slit or the other, and when it does, it hits the screen. And this experiment has been done not just with light, because light's kind of a magic thing, right? Travel speed of light, massless particle and all that. They did it with electrons. They've done it with hydrogen atoms. They've done it with all sorts of particles, massive particles. The biggest one they've done this with is buckyballs. That's 60 carbon atoms, like a soccer ball configuration. Big molecule, works just the same. So it's not just light. So you can imagine that this is a massive particle, but we'll talk in terms of photons because that's the way it was done at first. Well, they did that. One photon at a time, they fired at this thing, and guess what happened? Well, after they fired a whole lot of them, one photon isn't enough to really detect in those days. So they fired, thousands of photons, but one at a time. They expected this, they got this, the diffraction pattern. Okay, now how could that happen? That was a mystery. So they decided, well, let's see what's going on with these slits. So these little red squares here represent detectors. So they put detectors at the slits to see what was going on. And when a photon passed through this slit, you get a little blip on the detector, which then was recorded on some kind of data recording device. And sure enough, it created a little spot of light right behind it. So when they had the detectors detecting, they got this pattern, not that pattern. Well, the only difference appeared to be the detectors. So it was like the detectors are doing this somehow. Okay, the next experiment was to turn the detectors off, obviously. They turned the detectors off. They got this back. So it wasn't just the emplacement of the detectors. The next experiment was to let the detectors run, but don't collect the data. So the detectors there, they're detecting, they're sending signals, but the signals are just dropping on the floor. Nobody's collecting the data in any media. And what happens when you didn't collect the data? You got this diffraction pattern. Okay, now see, certainly reality is starting to look weird, isn't it? Starting to look very, very strange. Okay, this is sort of like, why don't people fall off the other side of the earth? There's something missing here in the understanding. Then they did another step that gets even more interesting, and that is they let these detectors detect. They collected the data, and you would expect that then you would get this, right? That's what you get. They collected the data. But then, before they looked at this, before they looked at that data, so it was in a computer someplace, let's say, or on tape in those days, before they looked at that data, they destroyed what they collected. What do you think happened? They got this diffraction pattern again, you see? So that gave them the knowledge that it wasn't the actual detectors, it wasn't the act of taking the measurement, it was the act of having the data available. Well, then that created one more experiment. They said, well, if that's the case, that's really, really weird, but let us test this thing. What they did next is they ran a whole bunch of these experiments. And for the point of being dramatic, let's say they ran 100 of them. Just one after the other, do one, then for an hour, collect data, for another hour, collect data. Just ran, duplicated the experiment 100 times. But they didn't look at any of the data from here or any of the data from the measurement screen. They put it in an envelope. So let's say they took this data, put it in an envelope, called it measurement screen, took this, put it in an envelope, called it detector 1 for, experiment 1. And then they took both those envelopes, they put them in a big envelope, said experiment 1. And then they did the same for experiment 2 and 3 and 4, all the way up to experiment 100. Then they took all this, they didn't really do this. I'm just making it dramatic and I'm giving you in a way that's easy to understand, or this is not actually physics protocol I'm telling you about. If they took that and they put it in a vault, let's say for a decade, that data just sat there for a decade. What they discovered happened, and these are called the classical erasure experiments. What they discovered would happen is that you could pull out one, okay, you pull out experiment 1, just randomly, pull out anyone, pull out experiment number 72. And if you just open it up and look at this data, and look at this data, you get this, just like you'd expect. That's what the experiment would be expected to do. But if you don't pull out this data, you leave this data in an envelope, you take this data, and you set it on fire, you burn it. Okay, this is 10 years later now after the experiment's done. In an objective world, the results of the experiment are already done, aren't they? You can't, they don't change in the envelope in the vault. If you burn this data before you look at the screen, you get a diffraction pattern. Okay? Now reality was really weird. You get a diffraction pattern. So they could randomly pick any of these envelopes, and by destroying the detector data, they would get diffraction patterns on the screen. If they did not destroy the detection data, they got 2 spots of light. So what does this tell you? Well, what it told the physicists of the day was go do something else. It's enough of this, right? Well, actually, it didn't tell physicists that right away. There was a group called the Copenhagen, now it's called an interpretation, but then it wasn't called an interpretation. It was just the Copenhagen conference or group, and they pulled all this together and said, this is the way reality works. And for the next 50 years, as questions would come up, like questions of entanglement and that sort of stuff, the Copenhagen group would say, here's the way reality would say it'll happen, and so far they've always been right. But the general physics community kind of wandered away from this because it was intractable. It was weird science, it didn't make sense, and nobody knew how to explain it. Well, the explanation is obvious. It doesn't need an interpretation. It's perfectly clear, and that is that until you open those envelopes up, the result hasn't happened yet. The result is still in the future. Okay? And what's important is whether or not you have the data of those detectors, which then will tell you particles went through these slits. If you have that data available, then the answer has to be this. If you don't have that data available, then the answer is that. So the result is not created until the present measurement, if you will, and the measurement in the present is when you open the envelope and decide whether to burn the data or not. So reality is basically created at the moment of measurement when we bring the data into this world. So let's go to the next slide, and I'll very briefly explain this. This is what they decided, and here's the physics answer to how this works, and it works wonderfully, is that particles are not really particles. Even though they're electrons or molecules or other massy things, they're not really that at all. They only look like that when we look at them. What they really are probability distributions, and that's kind of the probability distribution. It's like this: probability goes up and down, x goes from minus infinity to plus infinity. So that's what future particles look like, or let's call them, they're potential particles. They have a probable existence, but they don't really come into existence until you measure them and have the data to prove it, you see. So that was the answer of physicists, and you see what's going on here. This now is the present, where this measurement's being made up here. So this is still all in the future until the measurement's made, which means the probability went through both slits. So the particle is really a probability distribution. That probability distribution is called a probability wave. It's called a wave mechanics. And the probability wave goes through both slits, interferes with itself, and produces a diffraction pattern. That's the way the science works. Now, Albert Einstein has some quotes here. So these are the people now who did this work. These are the fundamental brains and scientists back in the early 1900s who were doing this work. And they made statements like this. Einstein says, reality is merely an illusion. Hence, it's clear that the space of physics is not, in the last analysis, anything given in nature or independent of human thought. Space is not independent of human thought. You won't find many physicists making statements like that these days because it doesn't go anywhere. It goes against this wall of, it doesn't make sense. Here's a letter from Einstein to David Bohm. David Bohm was a co-researcher with Einstein. They worked together. Einstein said, one has to find a possibility to avoid the continuum, together with space and time all together. Now, we have to get rid of the continuum, we have to get rid of space, we have to get rid of time. He says, but I have not the slightest idea what kind of elementary concepts could be used in such a theory. See, up against the wall. Okay, next is Eugene Wigner. He says, it will remain remarkable in whatever way our future concepts may develop that the very study of the external world, and he meant quantum mechanics, led to the scientific conclusion that the content of consciousness is the ultimate universal reality. Now, this guy's a Nobel Prize winner. He's not some New Age guy, handing out leaflets on the corner. We're talking about the very best of the best scientists at the time that were the inventors of these concepts and actually did the experiments. Max Planck, another father of quantum mechanics. Quantum mechanics had a sordid future, evidently, because there's lots of fathers. And Max Planck said, science cannot involve cannot solve the ultimate mystery of nature because in the last analysis, we ourselves are part of the mystery we're trying to solve. Right? Well, that's true. Einstein was saying the same thing. The space of physics is a function of our conceptual scheme. Well, what are they saying? Basically, they're saying what's out there, our reality, is somehow entangled with what's in here. Consciousness is at the root, you see. Okay, so summary, if we take from these statements, we can see reality is a product of consciousness. Consciousness is fundamental, and space and mass are somehow derived from it. Reality, particles, exist only as probability until they're measured and made and the data is available. Time and space are not continuous. They're digital. Okay? Well, these are kind of radical ideas. But here's Einstein, here's Planck, here's Wigner at the time, and this is going on now in the early 1900s, 1920, 1930. And it hasn't actually progressed any past that as far as understanding it. Actually, we've regressed. We don't understand it as well as we did then because we've ignored it. What we've learned to do is calculate. We've taken these as facts. Speed of light's constant. Particles are probability distributions, and we've learned to take those facts and just calculate all sorts of amazing things. Quantum mechanics and relativity are two of the most productive branches of physics ever. They're good. They tell you they predict experimental results. Okay, let's move up. Get some contemporary thoughts. Dr. Edward Fredkin started the digital physics movement about 1992. And now he did not come at it from quantum mechanics. Totally different approach altogether. He's a physicist working in information sciences, and he said reality is a computer itself, implemented on a computer, essentially digital, essentially informational. And of course, as soon as he said that, people asked Dr. Fredkin, if it's implemented on a computer in a simulation, where's it implemented, Joe? Where is this computer? And who wrote the programming for it? And Fredkin said, my science doesn't tell me that answer. It tells me, though, that my statements are true. That has to be the case, just like this tells you that has to be the case. Okay? So he said other. It's in other. Nick Bostrom. Now I'm leaping a decade at a time. I've taken samples a decade apart. 10 years later, in the early 2000s, Nick Bostrom, he's now head of a department in Oxford. Again, not a lightweight thinker. He wrote a paper called Are You Living in a Computer Simulation? And all these things are available on the internet if you want to look them up. And his result was he could not show even that it was unlikely that was true. Therefore, that remains a very real, in his words, even likely possibility. Okay, now here's a third person, approaches it from a totally different view, another decade later. This is now 2010, right? He's written a series of 3 or 4 papers. The Physical World as a Virtual Reality was his first paper, Brian Whitworth. The digital physics movement started in 1992 with Fredkin. There's hundreds of physicists that call themselves digital physicists. Not like this is just, 2 or 3 people talk about this, over beer, at night. This is there's a lot of physics going on working in this area. That's why I say it's hopeful. Science is moving in this direction. Okay, what Brian did is he said, all right, we have this idea that reality is simulated. It's a virtual reality, and we have the idea that reality is objective. So let's just look at all the facts we know, the results of all the experiments, the things we know that are true, and see which one of these, is the better descriptor of our reality. Which one works best? Which one solves the problems and has fewer problems of its own? He did that in a big matrix, and at the end of his talk, his conclusion was, physicists, wake up. A virtual reality, assumption of a virtual reality is better physics. It fits the data better, answers more questions. Okay, so that's where we're going. That's kind of a contemporary thing, decade at a time. All right. Let's try to rush on forward. We're going to talk a little bit now about consciousness and reality. Okay, consciousness is the fundamental reality. If you decide to do the books, and they're free on Google, by the way, entirely, you'll find this is derived, but I'm just going to state it now. Consciousness is the fundamental reality. Matter of fact, this is the only thing that's fundamental. Everything else other than consciousness is virtual. It's a derivation of consciousness. Consciousness is an information system. I call the larger consciousness system, that's a digital information system. At the most fundamental level, consciousness is just information. Information, the most fundamental level is bits. Bits, the most fundamental level, are binary. Okay? Now, I'll tell you a little something to make this more palatable for you. What is your reality right now? What's this reality? What you're hearing, what you're seeing, what is it? It's just information. It's even digital information. You're getting light beams, you're getting acoustic waves, they all get into your sensors, right, for your body, your senses. And what do they turn into? Electrical signals, right? Eventually they turn into patterns of neurons. That's just digital information. So your reality is indeed just digital information. And you take those patterns of neurons and those electrical signals and you interpret them as this reality. It's just an interpretation from the data you get, digital data. Okay, information is non-physical and it's subjective. Okay, two properties. Now you think information is non-physical? That's only a question if you can't separate the difference between the information, which is the content, the message, the meaning, okay, from the media and the code symbols. The media is physical, the code symbols are physical. Let's take a book. The paper is physical, the ink is physical. You can put both of those in a bottle, but the meaning, that's not physical. You can't put the meaning in a bottle. It's non-physical, the message. And it's subjective because it's personal. If you receive data, you have to interpret that data. It doesn't come with some known interpretation. You interpret it. How do you interpret it? You interpret it based on your knowledge, on your beliefs, on your fears, everything that makes you up, your experience base, your database that is experience. That's how you interpret the data. So every one of us now is interpreting the data they're getting in their own way. Okay? That's why 5 people see the same accident turn in 5 very different accident reports, right? We all live in our own personal reality. We are consciousness. Okay? Information systems and evolution. We now have to talk about evolution. Information is a digital system. In a digital system is represented by organized bits. Now in physics we have this word called entropy. Entropy is a measure of disorganization. So if things are disorganized, you have high entropy. If they're organized, you have lower entropy. Okay, it's just a term. Comes out of thermodynamics, but it's a general term. Okay, example. Take a bunch of children's blocks and you just randomly toss them. There's no information. Put them in an order. So now we're putting some order in it. They may spell something, or they may just form a pattern. Patterns also have information. The block doesn't have to spell caterpillar. It can just spell, you can just have it. So let's say you have a block up, down, a block up, a block down, a block up. Where's the next block? Down, right? How'd you know that? Because there's information in the pattern. So you see, patterns contain information. Attributes of consciousness. Okay. Individual consciousness evolves toward lower entropy, higher quality, more spiritual states. Okay, now we're starting to get more strangeness, right? Love is the nature of a low entropy consciousness. Okay, now so here you have a self-modifying data system, if you will. It's called consciousness. It's a digital, non-physical information system. But it can modify itself. It has experience. It is aware of itself. Okay? I'm making leaps here, but that can't be helped in this short time. And what does it do? Well, it can either evolve or it can de-evolve. Evolve means more order, right? More information, more useful information. De-evolve means more randomness, less information. It's the only two things it can do. There is no stable state otherwise, and de-evolve is not a stable state. That's self-destruction. So the point of a consciousness, a digital information system that is aware and can self-modify, is to evolve. Okay. Now, how do we connect this with love and spirituality? It's a simple connection, and it's derived in the books, but let me give you just a short example that'll make it obvious to you. Let's talk about 2 groups, and these are going to be opposite kinds of groups. One group is a group of, let's say, 10,000 people, and they're going to be a little system. Okay, nothing comes in or out of the system, just these 10,000 people, and their relationships are all based on love. Okay, they're going to interact, they're going to live their lives, they're going to do what they do, but it's all based on love and caring. So what happens? One of their barns burns down, the rest of them all go over and build it back up for them. Somebody invents something or a better process to do what they have to do, it's shared, and everybody uses the process. Okay, now, is this going to head toward organization, toward more content, if you will? Is this going to evolve? Yes, of course. Give them, 10 years and they will probably have evolved up to the capacity of their system, because it's very cooperative, it's helpful, it's reinforcing, it's supportive. Okay, this builds more order, more content. Now let's take the opposite group. These are people who are full of fear, because the opposite of love is not hate. The opposite of love is fear. Okay, fear derives hate. Hate's a derivative of fear. So is belief. So is ego. All these things derive from fear. So let's take a fearful group. And this fearful group are all self-centered, right? Because they're afraid somebody else might get something they don't have, or they're afraid that somebody may take what they have. They're afraid it's all about them. Okay, now take that group. Now somebody's barn burns down. What did everybody do? Great, that guy's barn burned down. Now we don't have to compete with him anymore. Matter of fact, they may have set that fire to begin with. Somebody invents something. What do? Well, they keep it quiet so that they can profit from it. And what do other people do? They try to steal it away from him. And if they can't steal it, maybe they just go shoot him and take his stuff. This is just about me. Well, now how does that evolve? Are we building? Is this a thing that builds up, that evolves toward, or is this something that tears itself down? Every time it starts to build a little, somebody will tear it down, because this group of people and that group of people now don't like each other, and what do? They have a war. It kind of sounds like the place we live, doesn't it? Okay, so that gives you an idea of how evolution, entropy, and love are all connected in this consciousness system. Okay, so words like a low entropy system, a low entropy consciousness, is the same as a high quality consciousness, is the same as a spiritual or loving consciousness. So the more you lower your entropy, the more you become love. And not act loving. There's a difference between becoming and acting. Okay? There's a big difference. One is at the being level, the other is at the intellectual level. Okay? Consciousness works at the being level. All right, now look at the attributes of consciousness. Input, experience. It has to have experience, right? Memory. If you didn't have memory, every experience would be your first. Processing. You have to be able to compare experiences so you know which ones are better, and how do you know what's better and what's not? Purpose. You need a purpose. Well, in this system, the purpose is to lower entropy and evolve, to survive, is the purpose. And it has to be self-modifying. Now you look at these again and you say, well, that defines life. Look at the first cell in this biological realm, in this physical reality. It had to have input. It had to sense something about its environment, or how could it evolve according to its environment? It had to have memory, even if it's at the cellular or DNA level. It had to have memory, otherwise you could never tell if you're getting better or not. It had to have processing. It had a purpose, which was survival and procreation, right? That's our physical evolution driver. And it had to be self-modifying, or it'd still be the same. Okay, so these are the same attributes of life. Consciousness is life. Consciousness is what's fundamentally alive in us, not these bodies. All right, so let me just run through a real quick summary, because I've gone very, very quickly. I'll read through these fast. Consciousness is best modeled as a superset, a self-modifying digital information system capable of computing virtual realities. The larger consciousness system evolves by lowering the entropy of the system. It lowers entropy of the system by organizing the bits at its disposal in a more profitable configuration. Content creation and reorganization opportunities are generated by using conscious intent to apply free will choice to incoming experience data. Okay? Feedback of the results of previous choices allow us to modify future choice. Okay? So that's kind of where we've just been. Now I'm going to explain to you, where do we come from? Individual existence. Well, okay, here you have this big monolithic consciousness system. It's non-physical, it's information, and it needs to evolve. Okay, how does it do that? It needs experience. Well, it has to just experience itself. That's a slow track. It can't, that's a very slow track. The biological cells found out the same thing on the other side. What did they do? They multiplied, right? You had a one-cell thing, then you had a two-cell thing, and then you had a many-cell thing, and pretty soon the cells were differentiating. You had the locomotion part, and the feeding part, and the digestive part, the eliminations part. Because why? That's a lower entropy solution. That's more organization, you see. Well, the consciousness system, what could it do to improve its evolution? The same thing. It could split apart. Now you had lots of little subsets of consciousness interacting with each other, making choices, growing. Very soon, these all became different because they all had different experience. So they all had different, we said we create our own reality from our own set. We have to interpret the data. Well, they're just exchanging data. They all become unique beings, if you will, subsets of consciousness. That's you and I. That's all of us. That's what we do. And now you see that what we are is part of the larger consciousness system strategy for evolution. As we evolve and lower our entropy, the whole system evolves and lowers its entropy. You see, we're part of a larger system. And that also defines things like morality, what's good, what's bad. What's good? What's good is what lowers your entropy. It's what helps you grow toward love, toward being love. That's what's good. What's bad? It's the things that take you the opposite direction. So it's a split between fear and love. Creating physical reality. The last piece of the puzzle that you probably want to know about is, okay, that's consciousness. That's the what fundamentally exists. So, and now we know what we are, right? We're a piece of that consciousness. And being a piece of that consciousness, guess what? You've heard this phrase, we're all one. We are. That's literally true, not just a warm, fuzzy saying. It's literally true. And we're all netted. We're all connected because it's on a big, giant net. In the book, I call it the reality wide web, but it's very much like the web we're used to. But we're all plugged into the same thing because we're all part of one thing. All right, but where does this physical reality come from and why is it here? If you're going to produce effective interaction, that is, if you want to implement this evolution, then you need experience. If you're going to create an experience, you need to have experience with feedback, with purpose. Okay, first thing, you need a goal. We have that. To lower the entropy, become love. Now you need structure. You need constraints. Constraints are what define the limits of interaction within a rule set. Now we're talking about this rule set. They define the content of the interaction. Without rules, there's nothing that you can do. There's no traction. There's no decisions other than personal ones inside your head. Well, here's an example. Let's say there's 5 of us. We all get together. We're going to play a game. So here we are. We all sit down and we say, "All right, go." What do we do? Or, what can you do? Right? What's the game? What are we supposed to do? What are the rules? Right? Until you have rules, there is no game. The game is created by its constraints. You see. The game's created by its constraints, and the same with us. So this reality is a set of constraints. Well, what are the constraints? Physics. Now, when I say physics, I don't mean the narrow set of physics. I mean physics, biology's physics, chemistry's physics, a physicist's view of the world, right? Everything is physics. But by that I mean the basic way that the physical world interacts and works together. I call it physics. So our physics is the rule set, and we've dug out a fair number of the rules in the rule set. It's called our science. But that's the rule set. Now, where did this physical reality come from? Well, you've heard of the Big Bang. Now think of the big digital bang. And we have big digital bangs in our computers. Those people who are cosmologists who try to simulate the Big Bang. Okay, so think of the same thing. So you have a computer. What's a computer? It's a digital information system, right? It's consciousness. Dr. Fredkin, other consciousness is the computer. Okay. And we're pieces of that. So anyway, what do? Well, you start with a lot of energy, you put it in a tight space, you come up with initial conditions, and then you hit the run button, and what happens? Well, that energy, because it's so tight, it expands, and as it expands, it cools, and as it cools, you get bodies, you get solar systems, you get stars, and some of those have planets, and some of the planets are like this one, and then you get one cell, get the right amino acids together, and you get a cell, and then a multiple cell, and here we are, sitting in an auditorium. So you didn't make a very fast pass at it. So that's what happens in this big digital simulation. So this big digital simulation, as Fredkin said we must have, is an information system. And it's an information system based on probability of all the things that probably could happen given from where we started. Okay? Now, why do we have this? Why develop that? Why would the larger consciousness system develop such a thing? Because now we can have rules to play the game. We can have experience. We can interact in a schoolhouse that has immediate feedback. If I go up and stomp on your foot or something, I get immediate feedback, whether that was a nice thing to do or not, right? I get fast feedback, which isn't the same if you're just trading data and interpreting it. You see, there's no traction there for making decisions, getting feedback about the quality, about how much love is in is in that decision that you make. Okay, so that's why we have this physical reality. It's a schoolhouse, if you will. We, as parts of consciousness, okay, get the data stream, and we interpret it as this. And it's a multiplayer game. That's why we're all here. It's a multiplayer game. It's very much like the games you play on a computer. It depends on how old you are. You know, I never played a lot of virtual reality games with my kids. I couldn't get them away from the computer long enough to do their homework, and I imagine most of you either in that situation or are familiar with it. So these work the same way. Okay, everybody is walking around in their own reality. Every computer on the desktop playing World of Warcraft or whatever gets its own data stream, and that creates that reality. So that's the idea. Okay, that's physical reality, a schoolroom where consciousness can interact. And why? To lower its entropy, to grow, to become love. That's why we're here. That's our purpose. That's our point. We are, if you might think, the working fluid in a big evolution machine. You see, we are part of the process of evolution of the larger consciousness system. That's our thing. So we hear these nice words, about holism, about love, and love heals, and looking at big pictures. These are not just nice ideas. This represents the fabric of our existence. That's how reality works. That's what it's based on. All right, let's go on to another one. We have one more step in this process, and that is we've kind of talked, I say derived the larger conscious system. We haven't, because we didn't have time, but we've talked about individuated units of consciousness, where you and I come from. We've talked about physical reality, what that is. And next is the last piece of this that we'll go through, and that's how does it work? How does this virtual reality work? Okay. Well, I told you, we have feedback. Choice, the choices you make modifies the future probability, which modifies the choices you have to make next time, you see. It's a feedback system. There's two databases here I'd like to tell you about on either side of the present moment. I'll describe them very quickly because these then help you understand everything else that goes on in this reality frame. Okay. The first, I have to tell you about the probable, future probable reality. Okay, now if we're a data system, right, what this data system does and how it interacts with us here is that it increments, like any simulation, a delta t at a time, right? Every delta t, you update the simulation. Well, in our case, the delta t is about 10 to the minus 44 seconds. It's very, very fast. All right, that's a nanosecond. That's way smaller than we have any ability to measure. Okay, but that's our delta t. That can be computed. So every delta t, the simulation updates. Now, that then defines the present moment. We are in some delta t. Now, we make choices within that delta t. We have free will to make those choices. Free will is not you get everything you want. Free will is you have a certain decision space, and that decision space defines the size of your personal reality. That decision space is a collection of all the decisions that you can make. Not necessarily all the decisions that are possible, because there's some decisions you can make that you just don't know about. They're outside of your reality, outside of your, of what you know. So it's just what you know, the decisions you can make. And within that decision space, you have free will to pick one of those decisions. You can go take this path, you can take that path. Okay? You can get angry when I stomp on your foot and stomp back, or you can say, excuse me, and see if I have a problem. Am I having a problem walking, or what's the issue? So you have decisions about how you react to everything. And if you make these decisions well, with love, you evolve the quality of your consciousness. If you make them poorly, with anger, with fear, you de-evolve the quality of your consciousness. Okay? So you take what we are now in this delta t, then we just compute what's most likely to happen in the next delta t. And assuming that that's correct, then we'll take that as the basis and say what's most likely to happen in the next one. And then the next one, and the next one. So each one is based on the accuracy of the one before it, so eventually it gets pretty ratty, right? It doesn't get too accurate if you go far enough out. But you can do this, and when you do it, you have created what I call the future probable database. So it's everything that possibly could happen, every choice that could be made, and the probability that it will be made. So it's a big probability distribution of everything that could happen. Then you have the present moment where free will lives, and we actually make decisions and do things, make choices for our evolution. And then on the other side of the present moment, after we go to the next delta t, that old delta t now becomes the past, right? That's the history. And it's just one big historical database, but it contains all that probability information. So it's everything that, you actually can break it into two pieces. Everything that could have happened, but didn't, and all the probabilities that it would have, and everything we actually did happen, which you string those together through the database, that's our history. Everything that actually did happen because of our choices that we made. Okay, so that's the structure of it. And just with that structure, you can understand all sorts of things. Out-of-body experiences that are in what Bob called locale one, which are kind of had to do with this physical reality frame. All they are is accessing the database. Remote viewing, just taking data out of this database. And you can take it out of the past or the probable future. Remember, the probable future is only probable. It's just probable. Probabilities change. And when that next delta t we do something unlikely, well, the system has to calculate the effect of that and its ramifications all the way out. But, we're pretty predictable, particularly only at 10 to the minus 44 seconds at a time. We're very, very predictable. If you talk with your dead Uncle Fred, it's just data. It's data out of the historical database. Now, a historical database does not have free will. All the free will is at the present. That's us, right now, in the present moment. There's no, the characters, and you talk about characters, you get into these databases, it's like getting into a movie. It's like you're there. It's a very good database. It's not just like your library you're used to. You can get into any kind of scenario, and it's just like being there. It's just like being there. You can't tell any difference, but if you do experiments, as I have done, you find out that it's flat because it's just following the probabilities. And if you go back at the same scenario and start it with the exact same question in the same way, you get the exact same answer every time. It doesn't change because it's just probability distribution. That dead Uncle Fred is just probability distribution in a historical database because what was Uncle Fred now has moved on, doing something else, and we can talk about that if you want later. Examining past lives is data out of that database. Seeing auras, you're just getting data out of that database. Something I've done for 30 years. It took me a while to figure out what was going on and how it worked, but it's just data. You can define the output to be any way you like. It's your intent is what accesses the database. Reading tea leaves, tarot cards, horoscope. Okay, those are things getting into the future, probable database. Well, why aren't they always right? Because, it's just a probable database. Probabilities change, and because it depends on the interpretation of the individual doing it, which has its own issues. Precognitive dreams, intuition, all those things come out of the future probable database. Okay, now how do you heal with your mind? Well, I guess we'll get into that a little later. This is about health. You can heal with your mind, with your holistic approach. What you're doing there is modifying the probabilities of the probable future. You can change those probabilities with your intent, modifies those probabilities. Nature of virtual reality. Let's do this very quickly because I tend to overstay my welcome and talk too long. If you're playing World of Warcraft, or for you ladies, maybe the Sims games, okay, do the characters in the Sims or in the World of Warcraft, do they have to render oxygen for those characters to breathe? And of course not. That's ridiculous, right? They're not real. They're just computer characters. You don't have to render oxygen for them, but if your lizard man or your child in a Sims falls in a pool or gets in water too deep, what happens to them? They drown, right? Well, why do they drown? They drown because they do simulate the result. They don't have to simulate the oxygen. They only simulate the result. And they drown because, obviously, a lack of oxygen, right? You can't breathe underwater. So your characters die in those simulations. Well, don't be too surprised, but we are exactly like that. This reality works that way. There's absolutely no reason to render oxygen in this room, only the effects of oxygen. It's a probabilistic reality. Okay, stretching your minds a little bit. But the way it works is that the reason we all sit in here and don't fall over is because it's probable that there would be oxygen in this room because of the trees outside and the plankton in the ocean, et cetera, et cetera. The rule set, the physics that defines everything says there's a good probability that there's oxygen in this room, so we all sit here and breathe. Okay? That's a different way of thinking about reality. It's dramatic, and but it lets you come up with a lot of right answers. Here's another one I like to do because it's fun. You've all heard if there's a tree, falls in the woods, and there's nobody there to hear it, does it make a sound? Okay? Everybody's heard that, and we think it's kind of a semantic puzzle, right? But here's the answer to it. There is no tree, there's no woods, there's no listener. They're all virtual, statistical, and probabilistic. Here's how that works. So the before scene, person walks into a woods. Okay, when he walks into the woods, let's say nobody's been in that woods before, he walks in and the system renders for him the woods according to the probability of what would be there. Okay, now remember, we all have our own personal data stream. So it just renders for this individual. So the individual goes into the woods and what's rendered is, say, a wobbly dead tree standing up. So the man walks out of the woods, comes back 5 years later, and he sees a dead tree lying on the ground because that would be probable. Because in 5 years with storms and you get the strength of the tree and the amount of wind that blew and so on, the rule set says that tree will be lying down. So when he walks in the second time, he sees a dead tree because that is probable. The tree didn't have to fall from this state to that state to go from standing. It just was rendered standing up. It was rendered lying down. See? No, let's see. This is hard, isn't it? That's, when I get it to you this fast, I know it's very hard to follow. But that's the way it works. Now let's even put a twist in it. Let's say he walked in that woods, and because it was probable, he got this dead tree wobbling, standing up. He walks out of the woods, and before he even gets out of the woods, he gets eaten by a bear. Now what happens? Somebody else walks into the woods the next day. Are they going to see the exact same thing? Maybe, maybe not. You see? Because now it will be rendered, when they walk into the woods, it will get rendered to them, but what is probable? Now, okay, if it was probable a day before, it's probably still probable today, but maybe not. What if the probabilities were such that there was a whole bunch of different things that were equally likely? Almost equally likely. Then you walk in the next day and there may not be a dead tree there anymore. You see? That's the way reality is. So I talked earlier about how the objective world is an approximation. That's an approximation in the case where the uncertainty is small. Okay? I throw a baseball. If I know the vector velocity of that baseball, and I know the air and the air currents and everything about it, there's tiny little uncertainty about where that ball is going to land. I can calculate it, to 15 decimal places. Very little uncertainty. Well, if there's very little uncertainty, it's approximately objective, and that's our objective world. But there's a whole lot of other world out there besides that, and this explains all of it. Now, consciousness experiencing a virtual reality generated by consciousness. Key idea here is that conscious intent changes future probability. And that's part of our system because that's the feedback. See, we make our own reality. Why is this reality we live in so messed up, so full of awful things? You just watch the news and all it will be is depressing. Why is it like that? Because that's a reflection of us being all the people that live in it. So the ugly and the beautiful are all there because it's all here among us, the people. We make this reality. It is what it is because we are what we are. All right. We all know that this is true, that intent changes probability. A long time ago, in 1957 or something, Norman Vincent Peale wrote a book, The Power of Positive Thinking. Well, we all know that. If you think positive, and you're always very positive, and you're loving, you care, things just kind of work out for you. You'll live a good life, right? Things are kind of happy. On the other hand, if you think negative and everything's awful and so on, you tend to have a lot of awful things that happen to you. But it's not all just that. There's also some randomness. There's some randomness in it too. Well, then what about prayer? Does prayer work? Well, yeah, it works. It's the same thing. It's intent. You get a bunch of people with an intent for something to happen. It changes the probability of the future. What about the placebo effect? We all know about that. That's what the drug companies have to beat in order to get their drug on the market, right? They have to beat the placebo effect. And that effect's getting harder and harder to beat. They're now going offshore. They're going to other countries to do their placebo effect testing because it's easier there than it is here. Why is that? Because we've been fed so much hype and so much junk from our marketers that we don't believe anything anymore. So when somebody tells you, oh, this is a great pill and it's going to, make your liver stop quivering or something, and we go, yeah, right. Whereas before we went, oh, wow, thanks, doc. You see, the placebo effect, changes. Okay? If your intent is focused on, yes, I'm going to get better, and you feel that way, and it's not just that you'll think you'll get better. Placebo effect says, you will get better. Well, not everybody, say 35%. That's the 35% that internalizes that message and really gets it at that level, changes their intent. The ones that go, they say that to everybody. It doesn't help them get better, okay? Because it doesn't affect their intent, okay? Let's turn this one over. Okay, now here's what I was telling you about. This is what defines what's objective. Sometimes we have, thing one is in a state, A, B, C, D, E, and so on. Now, I'm getting very abstract here, that's the way mathematics physicists do, but bear with me. It's very abstract. So thing one is in one of these states. And here's the probability function that describes it. Okay, that is describing a situation that is approximately objective. Because if you reach in there randomly and grab out what's going to happen from the probability distribution, well, thing one's always going to be in state F, isn't it? Because everything else is 0 and it's 1. So those are things with very little uncertainty, and that's what defines our objective reality. Things like that. But there's other things like that dead tree in the woods that have probability curves like this. And hey, it could just about as easily be E and G, F, or maybe even some of those others, right? So we have a lot of probability like that. And where does health fit in? It tends to fit into this. There's all kinds of variables. There's a lot of uncertainty when it comes to health. That's why these alternative approaches work. You see, there's a lot of uncertainty. You get a lot of positive energy going. You get a lot of love and caring. You heal people by giving them horses to ride, right? And playing pretty music. And you help the old folks by bringing a dog in for them to pet. Why do these things work? You see, because it changes their intent. It changes the way they're thinking. And that changes the future probability, which changes reality for them. Okay, so that's where we are here. Now, this is my next to last slide. You notice we already introduced this backward causality, and when we were talking about double slit, and that's where they took those envelopes, and 10 years after the fact the experiment was done, they can change the result, right? They can even make it come out as a diffraction pattern or 2 little points of light behind. And that's because it hasn't been decided. Nobody's looked at the data. It's still in the future what that data says. And based on the information, it'll be one way or the other. You see, we don't live in an objective reality. It only appears objective when we look at the rule set. Okay, now what about, in the hard sciences, what do the hard sciences do? Well, they only look at things that have very little uncertainty, right? Physicists, they're doing trajectories and they're doing things, the chemists and the biologists, they're all looking at things that are very tight. That's why they call them hard sciences. Well, what about the soft sciences? Well, the soft sciences, there's a lot more uncertainty in it. If you're a psychologist or a sociologist, now you're doing statistics, right, to see kind of where the lumps are. A lot of uncertainty. Well, what do we know about the soft sciences? What we know is that if you don't do them at least double blind, if not triple blind, your thoughts, your intents modify the answer. That's why you have to do the double and triple blind. Otherwise, people's thoughts change the results. Well, it's not just because you tell those kids in school that they're dumb, and the teacher thinks they're all dumb, so they all do lower, they all do lower scores. It's not just that it's the teacher tricking them, it's that they're changing the reality. They are going to lower their IQ because they're going to change their probable future based on that thinking. All right, so backwards causality is not really backwards causality at all. What it is that the future, the present measurement, is of something that's in the future, and that future can change right up to the point that you bring the data into this reality. So you see, it's not really backwards causality. One experiment, if you're interested in these kind of experiments, go to Pair Labs. The P in Pair is Princeton. It's where Einstein worked. There's an offshoot of the physics department there that has just worked in mind influencing matter. They've done a whole lot of that. It's called Pair Labs. One of the things that people in this area have done is they've taken a radioactive source and got 2 Geiger counters on either side. The Geiger counters click whenever a particle goes through, and particles fly out randomly. So if you let these Geiger counters count a long time, they'll both have about the same number of particles in them. It's about equally probable it'll go either direction, right? So they'll do that. And let's say we do that 100 times. We use the same thing that we did with the double slit. So they do that 100 times. So they have the right and left detector, and they have this data. Nobody's looked at it yet. And they'll take these 100 times, and they'll ask people who are intuitive, who have ability to focus their minds, can you bias the counts in the right detector so they're always more than in the left detector? And they find out, yes, they can do that. Now, if you do it once, that's not unusual, because you'd expect every sample, sometimes the right should be higher, sometimes the left, not by much. Statistics will tell you exactly what the error bars are on the experiment. And within those error bars, though, you have uncertainty. And within that uncertainty, you can change the result. And you can change the result of an experiment that was done years ago that's never had the data looked at. See, it's the same thing as a double slit. It's all the same. The idea that quantum mechanics only applies to little tiny things is wrong. The concepts that underlie quantum mechanics underlie all of our reality and everything we do. These are general principles, not just principles that just work for little things and different principles work for big things. That never kind of sat right with me. But it's one principle and applies to everything. So they can do that, and these experiments have been done. They're so easy to do in the lab. They've been done over and over and over again. Paralabs has this little robot, and they've programmed the robot to move in random direction. Front, back, right, left, randomly. So what happens, you put it in the middle of a big round table, and it just wanders around in a little space at the center of the table. Random. Then you had somebody with an intent try to bias it, and that little robot, you can see it in the videos on YouTube, the little robot wanders across the table and falls off the edge. Okay? Because there's a little bit of uncertainty as to what the next random number is going to be. And in that uncertainty, there's a choice. And in that choice, it depends on how the random numbers are done. But if they're done right, there's a choice. And in that choice, you can modify it just a little bit. Now, when we modify those counts in those two Geiger counters, can they make one Geiger counter have 10 counts and the other have 10,000? No. They can only work within the uncertainty that the rule set allows. Okay? So out of 100,000 counts, this one may have 103, and that one has, less. It's just 100. So it's within that. So it's very small differences. But what's amazing, if you can take 20 of those things from the Geiger counter data and make all 20 of them come out 3 or 4 counts bigger for the right detector, well, that's the same as flipping a coin 20 times and getting heads every time. Now you're talking 1 in a million, you see, even though the result is tiny. All right, so that's backwards. One other thing, one other guy I'm going to mention before I wind it up, and that maybe you've seen on YouTube a guy called Dr. Emoto, and he thinks happy thoughts and he gets pretty water crystals. He thinks awful thoughts and he gets ugly water crystals. And he plays pretty music and he gets pretty water crystals and ugly music, Well, the idea then, of course, the water is somehow reacting to these thoughts, right? And the water is reacting to the music. That's not what's going on. You've all heard that no two snowflakes are alike. Well, when water freezes, the way the crystalline structure comes has lots of uncertainty in it. The reason the water gets pretty crystals when Dr. Emoto plays Beethoven is because Dr. Emoto likes Beethoven, not that the water likes Beethoven. You see, uncertainty can be affected by intent. So you need, as you do your experiments, many of you are doing experiments, taking data. You have to be aware of that sort of thing going on. And just as in the Erasure experiment, the data can come and go. Okay? If somebody looked at those Geiger counter data and they analyzed it and knew exactly what the counts were, and then you worked with your intent, it wouldn't work because the data was already in the reality frame. But then if that data got burnt before anybody looked at it, then you could change it. Even though they looked at it earlier, they no longer know what it is. So that's the Erasure experiment. It can come in, come back, back to the future, if you will. All right, that brings me to the end. If you want more information, you can get it at my website, www.mybigtoe.com. It's on YouTube. Go there and search for TWSCJR44. Google Books. The books are for free. You can get them at Amazon, Barnes & Noble, that kind of thing. Order them from your neighborhood friendly bookstore. The bookstore here at Emory does carry them. Okay, little things to wind up. As a physicist, I can tell you that reality is not objective. The scientific method is not always a useful process. Liberate yourself from the notion that it must validate everything. There is a place where it works wonderfully. There is a place where it doesn't work at all. Know the difference. Okay, our intent influences the probable future, but all intents do not carry the same power. To be effective, intent must be clear and focused for some point, for some amount of time. And generally we learn how to do that through meditation. Clear and focused. Intents generated by fear, ego, and belief are the weakest, but if persistent, you will eventually create what you fear. Most of your fear and most of your ego will be invisible to you. Okay. Individual health often contains large uncertainties and are thus modifiable by intent. Theirs, yours, and everybody else's intent. To leverage that intent to do the most good, you must see and treat each individual holistically. They're a whole being. of consciousness. You have to treat that whole being, part of the bigger picture. Beware, just like Dr. Emoto's ice crystals, results where there is substantial uncertainty are less objective and thus more susceptible to bias created by intent. You need to be aware of that. The placebo effect and the quality of your personal interaction with others. That's real medicine. That helps people get well. It's not that it's tricking them into thinking they're well. That's real medicine. Data not assessed immediately is more subject to intended bias. And in a probabilistic reality, almost anything can happen in the margins of uncertainty, and it often does. Always remain skeptical and open-minded. Eliminate beliefs, especially about your own work. That's all I have. Thank you very much.